In our late-breaking work 3DA, Assessing 3D-Printed Electrodes for Measuring Electrodermal Activity, we investigate if and how 3D-printed electrodes can be used to measure electrodermal activity. Electrodermal activity became a readout of the body's sympathetic nervous system, measured as sweat-induced changes in electrical conductance of the skin. Electrodermal activity has been used to estimate stress, workload, or arousal in user studies or interactive systems. Yet, the integration of electrodermal activity faces several challenges. Two electrodes are usually attached on two fingers at the hand, hindering the interaction comfort and application of electrodermal activity in interactive systems. This study presents a new method using 3D printing to make electrodes for EDA readings accessible, removing the requirement for the intricate assembly and attachment. We evaluate the sensing efficiency of different 3D printed electrode shapes using conductive PLA. We evaluate 6 different electrode shapes that we printed into 2 separate test beds. We evaluated the sensing efficiency in a user study with 6 participants. We use seed growth electrodes as a reference. Participants were conducting an auditory oddball task where they listened to sounds with different frequencies. A button must be pressed when a specific frequency was played. Our results show that circular electrodes show the highest correlation scores. The black lines indicate when the frequency was played and participants should press the button. Large circular shapes achieve the highest correlation. Our recommendation is to incorporate electrodes with increased skin contact area to enhance accuracy. Utilize flat-shaped electrodes to minimize contact resistance, opt for pointed shapes to enhance sensitivity, and select inwardly curved shapes to ensure resilience against motion interference. Thank you for your attention.